This is the NEET 2018 question from electric charges and fields. The problem is like this: an electron falls from rest through a vertical distance h in uniform and vertically upward directed electric field E, and then the time of the fall. So, let me take the case of the electron alone and talk about the time of the fall, right. So, let us consider an electron falling a vertical distance. Let that vertical distance that it is falling is h. Who is falling? An electron is falling. How is the electric field? Electric field is uniformly vertically upward. So, the first thing that we need to know is positive charge experience the force of electric field in the same direction of the field, in the same direction of the field, and vice versa. Means what? This is a negative charge. So, this experience the force against the direction of the field. Electron experience the force. How much is that force? Is F equal to EQ. I can write F equal to MA, that equal to EQ. So, A equal to EQ by M. That implies electron experience negative acceleration, that is why it slows down and finally it falls down, right, of how much? A equal to electric field applied, charge of electron by mass of electron. So, it is falling a certain distance. So, I can use a formula S equal to ut plus half at square. S is h, falling freely, ut is 0, half A means EQ by M, as I have explained, T of the electron square. That implies 2h into M by EQ equal to T electron square. So, time taken the electron to fall is root of 2h M by E. Q is charge of electron. That is with the electron. Now, look at the problem. The direction of the electric field is now reversed. So, I will take this next part of the problem separately. The electric field is now reversed, that is in downward direction. Keeping the magnitude say E, a proton is allowed to fall from the rest. Now, who is falling is not the electron, but a proton is falling. So, who is falling is now E plus. So, you know, a positive charge experiences the force in the same direction of the field. So, it experiences a force. How much is the force is again? F equal to EQ, MA equal to EQ. So, A equal to EQ by M. Here also it is experiencing the same acceleration. So, the time of the fall for the electron to find out, I can use the formula S equal to ut plus half a t square, half A T of the proton square, h, half A means EQ by M of the proton, because you are handling a proton here, into time of the proton square has to be taken. That implies time of the proton square is 2h into mass of the proton by EQ, that is time taken by the proton to fall down is square root of 2h into mass of the proton by EQ. E is again charge of proton and electron same. So, when you compare this equation with this equation, 2h are same in both of them, electric field and charges are same both of them. So, what is different here is the mass of electron, here is the mass of the proton. So, as we know the relation that mass of the electron is much less than the mass of the proton, that is approximately 1840 times. Time taken the electron to come down is much smaller than the time taken by the proton to come down. So, the time of the fall of the electron in comparison with the time of the fall of the proton is smaller, it is not equal, it is not greater by any number, it is smaller. That is how we solve the problem. So, the only simple thing that we use is actually equation of the motion and nothing big, only F equal to EQ, that is all. Very definition of electric field, as electric field is the force experienced by the unit charge when placed in a electric intensity is the force experienced by the unit positive charge when placed in a field. From that I can write F equal to EQ, that is very definition of electric field intensity. So, to solve this problem you only need to know definition of electric field intensity and S equal to ut plus half at square, both are quite simple things. That is it, and thank you for watching.